Right now, over 400 million tons of plastic are produced every single year. A simple plastic bottle you use for 5 minutes will survive on this planet for over 450 years. Even worse, it breaks down into trillions of invisible microplastics, now found in our clouds, our oceans, and even our own bloodstreams. For decades, scientists told us there was no real solution. Paper straws get soggy, bioplastics are too expensive, and recycling? Less than 9% of all plastic actually gets recycled. But what if a material had the exact strength, flexibility, and heat resistance of industrial plastic, but could completely self-destruct into harmless soil in just 6 days? Researchers at the Chinese Academy of Sciences and leading forestry universities have just unveiled 2 radical inventions that could end petroleum-based plastic forever. Welcome back to Zero to AI. Today, we break down the science behind China's new living plastic and the materials revolution about to change our world. To understand why this breakthrough is causing shockwaves across material science, we have to look at why current bioplastics have failed. In recent years, products made from cornstarch or sugarcane, like PLA, promised to save the planet, but they came with 3 fatal flaws. First, they aren't truly biodegradable in nature. A standard PLA cup requires industrial composting facilities heated to 60 degrees Celsius with specialized enzymes just to break down. If you throw it in normal soil or the ocean, it stays intact for decades.
Second, they are brittle. They melt at low temperatures and shatter easily under stress. And third, they take arable land away from food crops. Scientists needed a material with the tensile strength of industrial polymers, capable of surviving extreme manufacturing heat, yet programmed to disintegrate on command without leaving toxic microplastics. And that's where the Chinese Academy of Sciences made their revolutionary leap.
Published in Nature Chemical Biology, a research team led by Dr. Dai Zhuo-Jun at the Shenzhen Institute of Advanced Technology introduced a concept that sounds straight out of science fiction: living plastic. Here is how it works. The researchers used synthetic biology to engineer a common, harmless bacterium called Bacillus subtilis. They programmed these bacteria to produce powerful plastic-eating enzymes. But here's the genius part. They encapsulated the bacteria into ultra-resilient spores. Bacterial spores are nature's ultimate survival capsules. They can survive freezing, radiation, and temperatures exceeding 150 degrees Celsius. The scientists mixed these dormant spores directly into raw plastic pellets during manufacturing. As the plastic is melted, molded, and cooled into bottles, utensils, or phone cases, the spores remain locked inside, completely asleep. During everyday use, the plastic behaves just like any durable, high-grade plastic. It holds boiling liquids and resists physical impacts. But the moment that product is discarded into soil or a compost pile, moisture, trace minerals, and environmental triggers crack the outer layer. The spores wake up. Within hours, millions of microorganisms begin secreting specialized enzymes.
While living plastic handles single-use packaging, China's second breakthrough targets heavy industrial manufacturing: bamboo molecular plastic. China is home to over 7 million hectares of bamboo, the fastest-growing plant on Earth, capable of growing nearly 1 meter per day. Historically, using plant fibers for plastics resulted in weak, rough materials because plant cellulose is locked in rigid hydrogen bonds. But material scientists at Northeast Forestry University developed a green solvent process that dissolves and completely reconstructs bamboo cellulose at the molecular level.
The result? A dense, transparent, moldable biomaterial that achieves a tensile strength of 110 megapascals, matching or exceeding petroleum-based plastics, with thermal stability above 180 degrees Celsius. When buried in garden soil, it naturally biodegrades in 50 days. Even better, it supports closed-loop recycling, retaining 90% of its structural strength after being melted and reformed. China's government has already launched the national Bamboo for Plastic Substitution initiative, aiming to replace millions of tons of single-use daily plastics across the country.
The implications of these two inventions are massive. Today, the global packaging industry is a $1.2 trillion market. For decades, fossil fuel companies argued that petrochemical plastics were the only cost-effective solution. But as synthetic biology scaling accelerates, living plastics and molecular bamboo are approaching cost parity with traditional plastics.
More importantly, this changes the philosophy of materials engineering. Instead of designing materials to be indestructible forever, we can now program an expiration date directly into the matter itself. A delivery box programmed to last 30 days. A food container programmed to last 2 weeks after opening. An agricultural film that dissolves automatically into fertilizer right after crop harvest. What do you think? Would you trust a bottle infused with living bacterial spores? Let us know your thoughts in the comments below. If you found this breakdown insightful, hit that like button, subscribe to Zero to AI, and tap the bell icon so you never miss the latest breakthroughs shaping tomorrow's technology. Thanks for watching, and we'll see you in the next one.
Plastic was one of the greatest inventions of the 20th century, but it created our biggest environmental nightmare. With synthetic biology and molecular plant engineering, we may finally have the tools to replace petrochemical plastic once and for all, not by asking consumers to sacrifice convenience, but by inventing smarter materials.